Hey guys, today I would like to show you how to evaluate an interesting integral called the Gaussian integral, which pops up in a lot of different branches of physics, as well as the fact that this is kind of a cool integral to show your friends. It's a neat integral because it can't be evaluated with U substitution, and you have to kind of devise a clever method to evaluate it. The clever method that I speak of will be the following. Let's go ahead and call the result of this integral I. We don't know what I is yet. We can write I legally as negative infinity to infinity of e to the minus y squared dy. There's no problem doing this. It's just x and y here are dummy variables. They both mean the same thing. For the fun of it, let's just go ahead and take the multiplication of I with itself. I squared equals negative infinity to infinity of e to the minus x squared dx times negative infinity to infinity of e to the minus y squared dy. This here is just taking one I times another I, which we defined previously in this manner. Now, using our rules of integrals, we can rewrite this as negative infinity to infinity to infinity of e to the minus x squared plus y squared dx dy. Here, I've just combined the since we're using the same exponent, they're going to be or since we're combining the same base, they're just multiplied together, and therefore we add the exponents. Here, this integral looks a lot like something that could be evaluated with polar coordinates, and indeed that's what I'm going to do. Let's make the statement that r squared is equal to x squared plus y squared, which is just a regular old polar coordinate statement. And let's go ahead and convert this integral into polar coordinates, remembering that we need the integrating factor, or the Jacobian, r. So this is going to be the integral from 0, so I squared, remember, is going to be the integral from 0 to 2 pi, the integral from 0 to infinity of r e to the minus r squared dr d theta, where I have simply substituted x squared plus y squared for r squared, and then added the r term from the Jacobian. Now you'll notice that this term right here has no dependence on theta, and so this integral of d theta over 2 pi is just going to be 2 pi. So we're going to get 2 pi, so remember I squared equals 2 pi times the integral from 0 to infinity. Whoops, sorry guys, can't see that. I squared is equal to the integral from 2 pi from 0 to infinity of r e to the minus r squared dr. Here, this looks like a very, very simple u substitution, and that's exactly what I'm going to do. Let's say u equals r squared. Therefore, I can say du dr is equal to 2r. Let's go ahead and do some algebra. Du equals 2r dr, therefore dr equals du over 2r. So now let's make a substitution for dr, and let's make a substitution for right here for u. Let's plug these into the integral and evaluate it. So then we get 2 pi times the integral. Now if we check our limits, let's plug in 0, it's going to be 0. Let's plug in infinity, it's going to still be infinity squared, so it's just going to be infinity of r e to the minus u times du over 2r. These 2's cancel, these r's cancel. We now get pi times the integral from 0 to infinity of e to the minus u du. Now, what's the integral of e to the minus u? It's simply minus e to the minus u. So we get pi times minus e to the minus u of pi 0. Let's plug this stuff in. Pi times minus e to the minus infinity minus e to the minus 0. This here, e to the minus infinity, is 0. This goes away. This e to the minus 0 is just 1. Minus and minus reinforce, we get plus. So we simply get that this entire thing evaluates to pi. What is this entire thing we speak of? Remember, it was I squared. So therefore, I must equal the square root of pi. Now this result is completely general. You can completely generalize this result, and I'll leave it up to you as an exercise, that if you have any arbitrary constant up here, a, such that you have the integral from negative infinity to infinity of e to the minus ax squared dx, then the result is simply, if you come back down to our result, then it's simply I equals the square root of pi over a, where this a is the same constant that I defined, and that's a cool way that you can derive it, and it's a nice mathematical trick that you might show your friends sometime. Alright, see you later, guys.